So far, all of the programs we have written have done the same thing every single time, and there was no way for the user to actually make any changes to the program when it was running. The only way you could actually change the program was to change the code. And as we know, whenever we're using a computer, we're not constantly changing our computer's code to be able to make it do different things. So we allow the user to add input, and so the program can do things based off of that input. And so input in the context of what we're writing lets the user enter data into our program. And so the program can do different things based on the data that they enter. Output can change depending on what the user wants to put in. So the best way to learn input, I think, is to look at some examples and convert a bunch of programs to use input. So we're going to start pretty basic here, and we have a program called age.c, and right now all we know age.c does is print out two people's ages, your age and your friend's age. But for most of you, you are not 5, and most people's friends, well, they may have a friend that's 10, but not always. So we want the user to be able to change these numbers so that the output is different. So we're going to add a scanf statement. Instead of printf, we are scanning in something from the keyboard, the input that the user has entered. And the scanf starts the same way that you would a printf statement. It starts with a double quote. In the double quotes, you specify what kind of data you want. And in this case, we want an integer. And so the symbol is the same as our printf statement, %d. Now it needs to know where to store the integer that it took in. And we do this same way with the printf statement. We write a corresponding variable called age. We end off our statement. So this looks very similar to the printf statement. There is one final difference that we have to change, and we have to put an ampersand in front of our variable name. This turns it into a reference, and we'll learn about references in detail when we learn about pointers. But what this basically allows this to do is it allows scanf to change the value of age to whatever the user enters. So whenever using scanf, you must put an ampersand in front of the variable you want to use. And so we're going to do the same thing for this one and have a scanf which accepts a integer type and stores it in our variable age, again changing the value of age, so when it is printed out here, it says something different. So this is our completed program. If we compile and run this program, it sits there blinking, does nothing. Now, the user might not know what to do, but we do. We know that it is going to ask for two numbers. So we should say, we'll say my age, okay, 19, and now we know it's asking for a friend's age, so I'll put 20. And it prints out your friend's age is 20. Now, as we know, it's not very helpful for a program to just sit there blinking, waiting for something, and you don't know what. So it's a good thing to ask the user for what the program is looking for. So enter your age. And then below here, enter a friend's age. Notice how I do not include a new line character. This means that when we run it, it's going to ask us right beside it. So when I enter my age, it writes your age is 19, and I enter a friend's name, I'll choose 22 this time, it says your friend's age is 22. Next, let's move on to our next program, this calculator program. Right now, this calculator program, all it does is it calculates the different values that associate with these two numbers. Now, the only thing that may look a bit confusing is it says our actual evaluation, our plus, our minus, our ampersand, right inside of our printf statement. We are actually skipping a step and not using another variable to store the answer. We're simply doing the calculation right inside of this printf statement before it gets printed out. So that is something you can do. You can modify a variable right inside of the printf statement. We want to change this and make it so we can accept two numbers. So we're going to remove these two lines so that way we can replace this with input. Now if we do it the same way before, we could write enter a number and we write a scanf. This time we're asking for an double variable type. And so we know that our little symbol is LF. Our format specifier is LF. This tells the computer to wait for a long type. Now if they don't enter a decimal point, that's okay too. It will convert it to 5.0, for example, if they entered in just 5 without a decimal point. Then we finish it off and we ask for a number 1. And then we'll say printf enter another number. And we'll accept our number 2. Now it says enter a number. We'll put 6.7 and enter another number again and 4.3. And now it does the calculations using those two numbers. If we wanted to ask for these two numbers on one line, we can do that the same way you would print out two variables. So if we say enter two numbers, we'll remove this and we'll put a second LF in there. And we say at number 2. This will cause the computer to wait for two numbers. And if we run this, let's say I enter 5.6 and keep going, it's going to keep waiting until we wait for two numbers before it does the calculations. You could also, for example, enter it on one line. So if I said 54.3 and 64.54, it would do that and accept it. Scanf is just going to wait for the first number and then say, okay, we need another number. So it's just going to wait there. You can enter anything until it actually gets a second number. Next, we have this program which converts a minutes and time and seconds into purely seconds. So if you entered in 2 minutes, it would say 120 seconds because that's how many seconds are in 2 minutes. Right now, it only calculates for 5 minutes and 56 seconds. So we want to get them to enter in two numbers. So if I say printf enter in your hours and your seconds, your minutes, sorry. And then I do it the same way as before. Scanf will accept two variables. We'll say we are accepting a integer and a integer. And once the first one will go into minutes and the second one will go into seconds. So this works the same way as we did before, except now it's going to convert it. So if I had a 6 minutes and 52 seconds, it will calculate 6 minutes and 52. What if you wanted them to enter it in like this, with the colon inside? You can actually place a character that it will look for inside of your scanf string. So if I write a colon there, it will say I am expecting a colon in between the two numbers. So it will extract the colon, ignore it, and then know that the two numbers on beside it are the two numbers we want. So now I can enter it in as so. 5 minutes and 30 seconds. And it will calculate that correctly. Finally, we have a program here called initials, and it takes in your initials. So if I write in initials.c and I run it, it will ask me for my two initials. So if I write RC, it will suck in those two initials and reprint them out for me. So that's already a working program, and we know we are using the percentage sign %C to take in a character. So that's all fine. Now let's say we wanted to add a friend's initials. Let's see if it all works the same way as before. So we say, let me clear this for us. Let's say we have, okay, so I'll put in my initials and then I'll put my friend's initials, and it will then go and print like this. Okay, so apparently it printed out the first set of initials, but then it kind of went wrong with the second set of initials. And we say R, and then for some reason there's another line here, and then it says the first one, V. So why is that? Well, what actually happens when you enter in RC up here, there's a third character that you also entered, and that's the new line character. When you press enter, you added a new line character into the input buffer, as it's called. So when it goes to the next line, when it says, oh, I need a first character, that well, it grabs the first character you have entered in the line of characters, and that is the new line character from before. So when you go and print it out later, it says, oh, there's a new line character, and that's why it prints out new line, and then it's like takes to the next character, V. So how do we fix this? Well, the easiest way to fix that is to actually accept the new line character. So if I create a new variable called new line, and then I take in a third character, and I just create this variable called new line, and I basically all I'm doing is I'm creating a variable that just discards new line. It stores it temporarily so that way it can be ignored for the next set of variables. So now when I update this and run it, I can enter in my initials and my friend's initials, and it will work correctly because the new line character is also accepted and stored in new line. We just don't print it out ever because we can always print out a new line if we wanted. But that's how we can avoid that issue and correctly take in characters.